Monday to Friday,
9 a.m. to 12 p.m.
This is the Morning Review with Lester Kibbert
on Cape Talk.
It's 25 minutes to 10 o'clock and the phone lines are already lighting up. It's that time of the week where we speak to the ever-popular Dr. Chris Smith, the naked scientist. Nice talking to you again, Chris. How are you doing?
Hi, Lester. Yeah, I'm good. I'm in good shape. How about yourself?
Very good. We are all, many of us, people over the age of 60 are getting ready to be vaccinated. About 120,000 so far in South Africa over the last 4 days and a bit. I'm still waiting for my jab in my arm. Have you had yours already?
Yes, because I'm a medical worker, I was able to access the vaccine as a priority, and I'm very lucky. And so I've actually had 2 doses of vaccine, both in January and more recently in April, because we've got a 3-month gap, or we did have a 3-month gap between doses here in the UK.
Well, let's go straight to that question first. Denise has been holding on since about 25 minutes past 9 o'clock. Good morning, Denise. You're speaking to Chris Smith, the naked scientist.
Good morning, Lester. Good morning, Doctor. I'd like to ask, Doctor, if by accident one is given an expired COVID-19 vaccine, how would it affect the body?
Hello, Denise. We set dates on these things which are supposed to make sure they are safe, and not just safe from the perspective of doing harm, but from the perspective that they will work. If a vaccine hasn't been kept properly, there's a danger that it won't work as well as one that's been kept well. And these vaccines they're based on a range of technologies, but they do have materials in them that will deteriorate both with time and with temperature. So by putting dates on things, we know that they are as safe as they can be. It doesn't mean, though, that if it goes over that date by, say, a minute or an hour or a day, it suddenly stops working. That's not how it works. But one would therefore have to take a pragmatic view. If it was just over a date, the likelihood of there being a problem with that is very remote indeed. On the other hand, if you got something that was a year out of date, that might be a very different story. So I think you have to judge this on a case-by-case basis. But if it's just an arbitrary date, in the same way that a best before date on some food in your fridge doesn't mean that the minute it goes over midnight and the date is yesterday, that suddenly the food has gone from perfectly edible to perfectly inedible, it just means that the quality might not be there, and therefore the benefit long term might not be the same.
Thanks so much for that, Denise. Let's go to Nick in Pinelands. You want to follow up on last week's question on taste and smell?
That's right. I'm just wondering, very interesting, the receptors in the nose and in the throat and all that. But what do they actually detect? I mean, does everything give off radiation or molecules?
Hello, Nick. The answer to this one, the answer is that when we smell something, what is happening is that molecules, which are called volatiles, in other words, they are things that can evaporate from a surface or from a body of material, engage with receptors, which can be thought of as a bit like a glove, and the molecule is the hand, and the fingers of the glove fit the fingers of the hand. So the molecules, which have come off of whatever the thing is that's producing the smell, are a particular shape and chemical characteristic, and the chemicals in a molecule will give it its shape and they'll give it its chemistry. That molecule will dock with or bind most tightly to a receptor, in other words, that's the glove, that's the best complementary shape that it is. And when the two come together, a chemical interaction between the molecule, which is the smell molecule, the odorant, and the receptor that's detecting it, cause the cell, which has got that receptor on it, to change its activity. And so everything is capable, if it has volatile chemicals on it, of having a smell. And what we call smell is actually the bouquet of different odours, the different molecules which are coming off of that thing. So no one smell is one pure, simple, single chemical very often. Most of what we call smell is a mixture of different chemical molecules, and it's the combination of receptors that get activated by those molecules that gives it what we call its smell or its odor.
Yeah, lovely. For example, I've got a pineapple ripening. When I first got it, it had a particular smell. Now it's ripe and ready to be eaten. It's got a completely different smell.
Yep, and plants are a really good example of this because as they ripen, the chemical characteristics of the cells, because they're changing their biochemistry as part of the ripening process, means that they do give off a different range of odorants and chemicals. And there's a number of reasons for this. If you think about what a fruit is there to lure in and tempt something to eat the thing so that it then disseminates the seeds and disperses them so you get baby plants all over the place and not growing all on top of each other. The best way you do that is by making it smell really attractive and appetizing and taste really nice to the thing that you want to eat it when it's ripe. So you don't want it tasting like that or smelling like that and being too attractive when it's unripe, because then it wouldn't have had a chance to ripen and mature its seeds, and that would harbour its ability to propagate itself. So plants do change the way they smell and the way they taste as they ripen in order to maximize the attractiveness to the creatures that they intend to exploit in order to distribute their seeds for them.
Chris, is everyone's senses subjective? As I can be, for example, colorblind, could I, in a sense, be taste or olfactory blind? I don't smell properly, or my brain does a neural chemical change to create a taste. Because there's a video going around on TikTok at the moment where people are sprinkling sugar over cucumber, biting into it, and they're saying to them it tastes like watermelon, for example. Is all your senses sort of subjective?
Well, the cucumber watermelon example is actually for a very good reason, and this is because those two particular fruits are in the same family. They're very, very similar in terms of their evolution and their genetics, and therefore their biochemistry, a cucumber versus a melon, is extremely similar, except that one tends to be a bit sweeter than the other. So unsurprisingly, because many of the same biological molecules are in both, if you put some sugar on there, you can make one taste just like the other. In terms of our ability to smell, humans do have a pretty good sense of smell, but not as good as some species, like a dog, for example. But there are people in the population who lose their sense of smell or never had it to start with. But there are also people who inherit genetically a particular trait that means they can't smell specific molecules. I believe that there's an example of this with freesias. This was noted by a guy called McWhirter in 1969, and the number of people who have that genetic trait is thought to be somewhere between 4 and 10%, and as a result, those flowers have no odour for those people. So it all comes down to, you have a gene, that gene encodes for a particular receptor which is expressed in your nose, and you have a constellation of those genes which make a constellation of the receptors in your nose that can detect different molecules, and therefore, by and large, given that most of us have most of the same genes, they're going to be able to detect most of the same smells, but there will be subtle differences from one individual to the next in terms of how much each of those genes gets expressed, how much, therefore, they can smell each individual molecule, and in some cases they may be missing a particular gene or it doesn't work in them, so they can't detect certain odours, so therefore certain smells will smell different to different people.
It's Friday, and it is the Naked Scientist here on the Morning Review on Cape Talk. Let's have a question via the voice notes.
Hi, Chris. We were wondering, we watch clouds, and when they dissipate, we wondered, we know the clouds are water vapor. What happens to the water vapor when the clouds dissipate? Thanks. Bye. Mary and Terry from Somerset West.
Hello, Mary and Terry from Somerset West. Well, the answer is, you're right, that when you're watching a cloud up in the sky, you're seeing water, but that's water which has condensed into droplets and, in some cases, ice crystals. And they're being held aloft by upcurrents, so rising drafts of warm, rising air from the Earth's surface are pushing upwards on these so-called hydrometeors and holding them aloft, and that's what a cloud is. Now, where those hydrometeors or water particles came from in the first place is that water evaporated from the Earth's surface or from rain on the way down to the Earth's surface. And when water evaporates, it is just individual water molecules or pairs of water molecules floating around in the atmosphere. And it's when they come together to make bigger groups of water molecules you actually get a droplet or an ice crystal. Now, that's a dynamic process, which means that some of the time there's water joining the cloud and adding to its bulk and making bigger water droplets and ice crystals, making the cloud look bigger. Other times there'll be water molecules leaving the cloud, because just by random chance and distribution of energy around all the different parts of the water crystals, you're going to have some bits which have enough energy to just break away and disappear off. So when a cloud disappears, basically what's happened is energy entering the cloud has dissipated and broken apart the associations between the water molecules. So instead of having big droplets or ice crystals in one place, they've now gone back to being spread out water molecules in the atmosphere. The water's still there, but they've all spread out instead of being together in one place, making crystals that you can see.
Thanks so much for that, Mary. Great question. Let's go to another one on the voice note line.
Dr. Chris, I do competitive walking, and which I enjoy, but I find after brisk walking for about half an hour and more, my nose starts running, and I don't have a cold, but it runs, for perhaps the next half hour or hour, and of course later it clears by the time I get to the finish line, which is about an hour later. What is the cause of my nose running?
This is fascinating, Chris, because my wife's a runner, and I would be the guy picking her up and clapping for her along the side of the road. And I've always noticed people with runny noses. I always just thought, okay, they're running when it's cold, and therefore they have runny noses.
I'm intrigued by competitive walking. I think my daughter is going for competitive sleeping, gold medal. The answer to this one is, what does your nose do? Well, your nose isn't just there to hold up your glasses or enable you to smell nice things or nasty things. It's also there to warm and to moisten the air that you breathe in. As I mentioned previously, in previous weeks, there is erectile tissue in your nose, which is richly supplied by blood. And in response to an increase in respiratory rate by colder air hitting the lining of the nose and more air going through your nose, you puff up this erectile tissue and make it moist and warm. And this has the effect of imparting to the incoming air extra moisture and heat, so that the air that then goes down into your lungs doesn't shock your lungs or dry out your air passages further down your lungs. Now, that means that there is an excess of moisture, or a surfeit of moisture, in the nasal passages, and so it's perfectly possible that some of that is collecting and condensing in your nose before it has a chance to disappear off with the airflow into your lungs, and then gravity takes over and it causes it to drip out. And I think that's probably the most likely reason why, when you start to exercise more, breathe in more cold air, you do tend to have your nose run more. The other possibility, of course, is you're exercising near something that you're a bit allergic to. But as that wasn't part of the question, noticing allergy or anything, and it seems to disappear quite promptly, I think the first answer is the more likely one.
12 minutes left to get your questions into Dr. Chris Smith, the Naked Scientist. You can call in 021-446-0567. Drop me a WhatsApp 072-567-1567. Let me reflect some of the text messages. This message says, Dr. Chris, I've read that the period pain women experience can be almost as bad as a heart attack. Why aren't we researching how to treat it? Do women naturally have a higher threshold to pain, or is this a myth? And it's actually quite topical. I see next week is also World Menstruation Health Day, so I think it's quite apt that we have this conversation right now, Chris.
It's really hard to study this. When people have done studies, and in fact there have been quite a few done, where, for instance, if you go and ask a woman, do you have bad or heavy periods? Then you get a range of answers. If you then back up your answers by asking people to keep what they collect and would normally perhaps throw away down the toilet or into the receptacles each month, and weigh them, which gives you an idea as to how much a person is losing in terms of blood, for example, you get a very different relationship between what people say they experience and what people are actually experiencing. So some people's definition of I'm fine, I don't really suffer badly with periods, would actually amount to torrential hemorrhage for other people. And so it's a really broad thing that's ill-defined, and because it's very subjective, it's really hard to know what is the right or wrong answer to this question. I think it really comes down to the individual, and you ask the individual, and it's what is normal for them, and within the bounds of what we accept is normal for women in general. And if something changes, that's when we also worry, because if someone has a certain set of period symptoms, but then they change and they've got a lot worse, then that tells us we need to worry about this. But in general, it is hard to study because it's one of those things where people, A, don't talk about it very much, B, it's not a topic of dinner time conversation, so people tend to suffer in silence, and C, it is something we can do something about. And for that reason, if people do think something's changed, or this is really quite disabling, you need to go and have a conversation with people, because actually there may be something that can be done either by better management, better pain relief, or there might be other problems inside, such as endometriosis. The condition endometriosis is very, very common. This is where you get some of the menstrual blood, instead of going downwards and outwards, goes inside the body, and it collects inside the abdominal cavity and seeds itself there, producing ectopic lining of the womb almost in the abdominal cavity. And this can produce excruciating pain. And many people who turn out to have very bad periods are being affected by this disorder. Again, something that can be managed. So it's really important. If you feel that this is a serious problem and it's affecting your life, you need to do something about it. If it's changed and has begun to seriously affect your life, you need to do something about it. And be reassured, people are extremely sympathetic to this, and there are things that can be done very often, and it can be investigated, and there are often quite simple ways to manage things and make it much more comfortable.
Chris, before we go to our next voice note, Bossy is asking, how did you become so clever, Chris?
Well, look, I'm the recipient of an amazing education, and I'm really, really lucky to have been educated and taught by some fantastic people. I was the first person in my family to go to university. And if ever there is evidence that getting a good education can change your life, it's me, because no one in my family had ever done anything other than very much working class type jobs, manual jobs and that kind of thing. And I was really lucky to have parents that were very far sighted and said, let's make sure we really push education. And they encouraged me and my brother to educate ourselves. And then once you get to a certain age and you begin to really relish and have a thirst for knowledge, you really find that it becomes an autonomous thing, and you encourage yourself after that. And so I went on to go to university, and I'd say it changed my life completely. So I would urge anybody, if you're offered an opportunity to grab any kind of education you can, it's the best thing you can do ever in your life. And better still, they can't tax you on education either. So another reason to get very well educated.
The best question and the best answer that we've had so far on the show. But let's go to a quick voice note. We're still taking your calls, your messages for Dr. Chris Smith. He provides us with an invaluable service here on the Morning Review, taking your questions 021 446 0567 or your voice notes on 072 567 1567.
Hi, Chris. How does a cell phone's touchscreen works? It's George McDonald from Stellenbosch.
Hi, George. Well, the answer to this is that embedded into the glass or the material on the front of the screen is a very fine network of almost thread-like wires. And they work as conductors, and they're arranged into a grid or crisscross pattern. And when you apply a part of your body, your fingertip usually, to the screen, what they're detecting is a change in what's called capacitance. Now, capacitance is the ability to store charge, and a big thing can store a lot more charge than a small thing. And because the phone knows, in inverted commas, what the capacitance of the different parts of that grid all over the screen are, when you bring your body part in contact with a particular part of that network, the phone can detect where the capacitance or the charge density has changed, and it therefore knows it's being touched in that area. And as you move your finger, it's tracking how that charge is redistributing and the capacitance is changing across the meshwork of tiny threads. And as a result, it can track the movement, both in terms of how hard you're pushing, how bigger area you're selecting, and how fast you're tracking your finger across the surface. And as technology has moved on, the ability to put more of those wires into a smaller and smaller area and do it in a way that's invisible, so you can't see them and they don't affect the viewing experience, that has moved on enormously. So the earliest touchscreens were absolutely awful at the resolution of sort of a whole fingerprint. But now we're at the stage where you can very delicately, as everyone knows, manipulate objects and stretch and shrink things and manipulate the visual image. And they're absolutely crystal clear.
I love some of the questions that come in, Chris, and this is really much in my wheelhouse in terms of how I see science and and also philosophy. This question asks, Dr. Chris, everything has a particular shape. The globe has a shape, the Milky Way has a shape. So what shape does the universe have? And that's a really, really interesting question.
No, we don't know because we can't see a whole heap of it, and we never will see a whole heap of it because it's growing faster than light can actually get to us from those reaches of the universe. So the light will never get from some parts of the universe to us. So we can only speculate, and we have this idea of the birth of the universe about 13.8 billion years ago being the Big Bang, where something which was dubbed a singularity, so a tiny entity, infinitesimally small, but with enormous energy, then suddenly began to inflate and blow up. And initially it did that incredibly fast. There was this period of very rapid inflation, which blew up like we presume, some kind of bubble or balloon. I mean, it seems logical to think that it would have expanded spherically, but who knows? And then it slowed down in its rate of growth, and over time it's then slowly speeding up again. But actually, what's there, what its ultimate shape is, what its dimensions are, we have theories, but very hard to test because no one's been there.
So why is it that simultaneously we can take? It's like, how can we then take a picture of the Milky Way if we are also in the Milky Way, Chris?
Well, it's a bit like saying, I live in, let's say I live in Cape Town. How can I take a picture of Cape Town if I live there? Well, you might live on one side of Cape Town. You can take a picture across Cape Town and you'll see Cape Town from the perspective of where you live in the city. And it's the same with the Milky Way. The Milky Way is a spiral galaxy. It's about 100,000 light years across. And there's probably a couple of 100 billion stars like our sun, or bigger or a bit smaller, smattered across that 100,000 light years of spiral space. And so we are on one edge of the Milky Way, on the outer edge, and when we look at the night sky and we see that strip of stars across the night sky, that's the edge of our galaxy stretching out into the distance away from us. So we're seeing towards the centre of our galaxy from the edge that we're perched on, and those stars are the other stars, or some of the other stars that we can see in the Milky Way. But our Milky Way is one of billions of galaxies which are out there across the universe at large. So we tend to say there are hundreds of billions of stars in each galaxy, and there are hundreds of billions of galaxies smeared across this universe bubble, which is expanding faster and faster and faster, and even giving birth to new stars all the time. It just boggles your mind to think how big this whole thing is.
It really does. I have literally 60 seconds to get through this one last question. This person asks, I used to change my exhaust on my car every year. Now I have to only change it every 5 years. Why? Is this because of the advance that we've made in catalytic converters, Chris?
Couple of reasons. Number one, they're using better materials, and instead of the material rotting out and they just get away with a cheap metal pipe, because they're using much more robust materials because of things like catalytic converters, which require higher tolerances and a stiffer, stronger material. The exhaust systems do tend to be more robust. I just got rid of a diesel car I'd had for about 15 years, and I hadn't replaced the exhaust once. It was a little tiny bit rusty in places, but previous to that, I was getting through an exhaust every 2 or 3 years.
Wow.